Hello everyone, this is Mr. Science Guy here, and today is a very special day. You may be asking yourself, well, why is today so special? Today is special because you are watching the very first episode of the Mr. Science Guy show. Together, we're going on an adventure of a lifetime as we explore the wonders of science and its effects upon our daily lives. Today, we're going to talk about things that are cold. What comes to mind when you think of something that's cold? Do you think of drinking a glass of nice, cold, iced water? Or do you think of enjoying a tasty frozen treat like a popsicle or an ice cream cone? Or maybe you think about going to a cold place like Antarctica. How cold is cold? Well, that depends. This glass of water that I'm drinking is about 40 degrees Fahrenheit. Your average ice cream bar or popsicle is usually around 32 degrees Fahrenheit. If you were to take the temperature of the inside of your average freezer, that's usually around 0 degrees Fahrenheit. And if you look at the average temperature for the continent of Antarctica, it's negative 76 degrees Fahrenheit. Now that's pretty cold, but what's colder than that? I have something inside of this container that is super cold. Something that is colder than water. Something that's colder than ice cream. Something that's even colder than Arctic air. Inside of this container, I have a substance known as liquid nitrogen. The liquid nitrogen is so cold that it literally boils when it's exposed to a room temperature environment. Today, we're going to explore an area of science known as cryogenics. You see, cryogenics is a study of how matter behaves at extremely cold temperature. The word cryogenics comes from the Greek word cryo, which means cold. The word genics means to generate, which is how we get the term cryogenics. Scientists like to use the word matter to describe anything that has mass and takes up space. Matter can be found in three main states: as a solid, a liquid, or a gas. Solids are materials that have a defined shape and volume, kind of like this rock. It has a defined shape and a defined volume. Liquids are a type of matter that changes the shape depending on the container that it's in. For example, I have a liquid inside of this beaker of wonder. And if I pour the liquid from the beaker of wonder into the flask of discovery, you'll notice that the liquid from the beaker takes the shape of the flask. Pretty cool, huh? And finally, we have gases, which is matter that spreads out to take up all of the space available inside of a container. For example, I have this balloon. Inside this balloon is air. If we were to pop the balloon like this, the air escapes and spreads out and mixes with the other air in the room. All matter is made up of molecules and atoms, which are very small. And sometimes when different types of molecules get very cold, well, they tend to behave differently. So today, we're going to discover what happens when ordinary things get super cold using liquid nitrogen. We're going to place a few strawberries, a racquetball, and a few marshmallows inside of our bucket of liquid nitrogen. Then, we're going to remove those objects from the bucket of nitrogen and hit them with a hammer to see what happens. I like to call this hammer the hammer of knowledge. Let's go ahead and place your objects inside the bucket of nitrogen. So here I have the marshmallow, the strawberries, and finally the racquetball. Right now, our liquid nitrogen is getting our racquetball, our marshmallows, and our strawberries super cold. Now, while those items are chilling out, get it? Chilling out? Science joke there. Let's take a look at this balloon of discovery. Now our balloon is inflated. It's filled with a gas. And the gas that's inside of our balloon is air. Now the air is made up of molecules, and right now the molecules are very, very warm. So what we're going to do is we're going to see what happens when we place the balloon inside of our bucket of liquid nitrogen. In goes our balloon, and let's count down from 5 together, and then we'll take it out. 5, 4, 3, 2, 1, and wow, look at that! Our balloon has shrunk, but as you can see before your eyes, the balloon is returning back to its original size. How cool is that? The molecules that made up the air got very, very cold. So cold, in fact, that they kind of had to squeeze in together inside the balloon. And when that happened, those molecules did not take up as much space. But as you can see, our balloon has returned back to its normal size because those molecules have warmed up and they're now taking up the original amount of space inside of the balloon. How cool was that? Some of you may be wondering, is liquid nitrogen dangerous? And the answer is yes. Liquid nitrogen can be dangerous. You have to remember, liquid nitrogen is super, super cold. It's so cold, in fact, that you can get frostbite, which is when all of the water inside of your cells of your skin freezes instantly. It hurts really bad. But instead, we're going to use these flowers to simulate what would happen if your skin came in contact with liquid nitrogen. We're going to place them inside of our bucket for about 5 seconds. 1, 2, 3, 4, 5. The flowers are out. Now let's see what would happen if I were to squeeze the flowers. 3, 2, 1. Wow! All the water inside of the flowers froze instantly. And therefore, the cells that make up the flowers became super, super brittle. So liquid nitrogen can be quite fun to work with, but you must be careful when you handle it. Now, we're going to remove those objects from our bucket, place them on our cutting board, and then we're going to use our hammer of knowledge to perform the scientific hammer test, which is a pretty easy test to do. We're going to hit each object with a hammer and then observe what happens. So now we're going to switch to the science cam. How cool is that, you guys? Those objects that we had inside of our bucket of liquid nitrogen just shattered into multiple pieces. The objects got very, very cold, and because of that, they became brittle, which is why when we took the hammer to each object, they simply shattered into multiple fragments. All right, you guys, we're getting close to the end of our episode, which means that it's time for a science alert. For our final demonstration, we're going to see what happens when you combine boiling hot water with super cold liquid nitrogen. Now remember, our liquid nitrogen is super, super cold. So what we're going to do is count down from 5 together, and when we get to 1, I'm going to take this insulated container that has hot water and pour it inside of our bowl of nitrogen. And then we're going to see what happens. Are you guys ready to count down? All right, let's count down from 5 together. 5, 4, 3, 2, 1. Wow! How cool is that, you guys? we just made a cloud on the set of the Mr. Science Guy show. That is super, super awesome. Wow, just look at that, you guys. As soon as we introduced the hot water to the cold nitrogen, some of that nitrogen evaporated rapidly, which is why we had a small cloud form. But wait, what if I were to tell you that we can scale this experiment up? If you want to see us do this experiment on a much, much larger scale, using triple the nitrogen and triple the water, then help us get 400 likes. We need you to share this video with as many friends as possible. Help us reach at least 400 likes, and we will scale up this experiment so we can create a 10-foot tall nitrogen cloud. So again, if this video gets 400 likes, we will scale up the experiment and we'll create a 10-foot tall cloud in one of our future episodes. Calling all grown-ups. To celebrate our first episode, we're giving away a free microscope. Not a toy microscope, but a real working microscope to one of our lucky young viewers. To enter the contest for a chance to win, all you have to do is 2 things. Number 1, be sure to like and share this video. And number 2, be sure to type the phrase hands-on WNC in the comment section below. Then you'll be entered in automatically for a chance to win. We'll be announcing the winner during the next episode of the Mr. Science Guy show, and we'll have lots of cool other prizes that we'll be giving away as well in future episodes. Well, that's all for today. Thank you so much for tuning in to the very first episode of the Mr. Science Guy show. Be sure to catch future episodes by visiting our website, handsonwnc.org, our Facebook page, and our YouTube channel. So until then, stay positive, stay healthy, be sure to wash your hands. We'll see you on the next adventure. Did you enjoy watching this episode of the Mr. Science Guy show? Help us spread the joy of science by liking and sharing this video with as many people as possible. Also, consider making a $5 donation to our Science for Kids Fund by visiting handsonwnc.org. You can also donate by texting the word hands-on to the number 44321. Proceeds from this fund will help us make new and exciting science content for the show, in addition to helping us reopen the Children's Museum. Thanks for tuning in.